All right, hello guys. So in this particular video, we're going to learn the Apache web server. Okay, so why don't we just dig right in? What is it? Well, as some of you may or may not know, Apache HTTP server is a free and open source web server, and it delivers web content through the internet. Okay, it's commonly referred to as Apache, and after development, it quickly became the most popular HTTP client on the web. It's widely thought that Apache gets its name from its development history and process of improvement through applied patches and modules. But that was actually corrected way back in 2000, and it was revealed that the name originated from the respect of the Native American tribe for its resiliency and durability. All right. Now, Apache is just one component that's necessary in a web application stack to deliver web content. One of the most common web application stacks involves LAMP, or Linux, Apache, MySQL, and PHP. Right, so Linux is the operating system that handles the operations of the application. Apache is the web server that processes requests and serves web assets and content via HTTP. MySQL is a database that stores all your information in an easily queried format. PHP is the programming language that works with Apache to help create dynamic web content. Now, while actual statistics may vary, it's fair to say a large portion of web applications run on some form of the LAMP stack because it's easy to build and it's also free to use. So, for the most part, web applications tend to generally have similar architecture and structure, even though they serve many different functions and purposes. Most web applications also benefit from firewalls, load balancers, web servers, content delivery networks, and database servers. Firewalls help protect the web application from both external threats and internal vulnerabilities, depending, of course, on where the firewalls are configured. Load balancers are going to help distribute traffic across the web servers, which handle the HTTP or S requests. And see, this is where Apache comes in. Application servers are the servers that handle the functionality and workload of the web app. And then we also have our database servers, which handle asset storage and backups. So depending on your infrastructure, your database and application can both live on the same server, although it's recommended to keep those guys separate. Alrighty then. So you know that the internet's comprised of many different technologies. Not all of them are the same, but while Apache is arguably one of the most popular web servers out there, there are many other players and the landscape is always changing. I'll take you back to the late 90s and maybe early 2000s. That's when Apache's dominance was very strong, serving over 50% of the internet's active websites. Microsoft's IIS, the Internet Information Services, was also an option early on, but not nearly as popular. And today, Apache still serves a large portion of the active websites, but their share of the field has kind of shrunk from about 50%, just under about 40% as of 2018. And then came Nginx. It's a relatively new player to the web server playing field. It's in second place with roughly 35%. Microsoft IIS is hovering around 8 to 10%. But every year, there's a new crop of web apps with new stacks and servers, so the landscape's always changing. So yeah, Apache is considered open source software, which generally means the original source code is freely available for viewing and collaboration. Now, being open source has made Apache very popular with developers who have built and configured their own modules to apply specific functionality, as well as improve on some of the core features. Apache's been around since 1995 and is pretty much responsible as a core technology that helped spur the initial growth of the internet in its infancy. One of the pros of Apache is its ability to handle large amounts of traffic with minimal configuration. It scales with ease And with its modular functionality at its core, you can configure Apache to do what you want, how you want it. You can also remove unwanted modules to make Apache more lightweight and efficient. Some of the more popular modules that can be added are SSL, server-side programming support, PHP, and load balancing configs to handle large amounts of traffic. Apache can also be deployed on Linux, macOS, and Windows. If you learn how to configure Apache on Linux, you can go ahead and administer Apache on Windows and Mac. See, the only difference would be directory paths and installation processes. I'll show you some of the features of Apache Web Server. Handling of static files, loadable dynamic modules, auto-indexing, HT access, compatible with IPv6, supports HTTP/2, FTP connections, gzip compression and decompression, bandwidth throttling, Perl, PHP, Lua scripts, load balancing, session tracking, URL rewriting, and geolocation based on IP address. So how does the Apache Web Server work? Well, it actually functions in a way to communicate over networks from client to server using TCP/IP protocol. Could it be any easier? So Apache can be used, for that reason, for a wide variety of protocols, but the most common is HTTP and HTTPS. So this Hypertext Transfer Protocol, or S, which is for secure, obviously one of the main protocols that you'll encounter on the web, and the one protocol Apache is most known for. HTTP and HTTPS is used to define how messages are formatted and then transmitted across the web, with instructions for browsers and servers on how to respond to various requests and commands. Hypertext Transfer Protocol Secure is usually through port 443, with the unsecured protocol being through port 80. Now, the Apache server is configured via config files, in which modules are used to control its behavior. So by default, Apache listens to the IP addresses configured in its config files that are being requested. And this is where one of Apache's many strengths come into play. With the listen directive, Apache can accept and route specific traffic to certain ports and domains based on specific address port combination requests. By default, listen runs on port 80, but Apache can be bound to different ports for different domains, allowing for many different websites and domains to be hosted on a single server. You can have domain1.com listening on port 80, domain2.com on port 8080, and domain3.com on port 443 using HTTPS, all on Apache. So once a message reaches its destination or recipient, it sends a notice or ACK message, basically giving acknowledgement to the original sender that their data has successfully arrived. Now, if there's an error in receiving data or some packets were lost in transit, the destination host or client sends a not acknowledged or NACK message to inform the sender that the data needs to be retransmitted. So Apache HTTP web servers are used by 45.1%, over 45% anyway, of all web servers in the world. So Apache web servers are actually easy to customize. They're fast, reliable, highly secure. So why wouldn't you want to use it? It basically makes Apache web server a common choice by best-in-class companies worldwide. Did I say worldwide? Worldwide. Now, Apache web servers are very popular. Great. But they're not the only web servers on the market. I'll show you a number of alternatives for Apache HTTP servers. Mentioned Nginx. There's Apache Tomcat, Node.js, Light TPD, Cherokee, Microsoft IIS, AppWeb, and Hiawatha. So simply put, Apache HTTP Server is a web server designed to serve static web pages, whereas Apache Tomcat is an application server built to serve Java applications. So web pages can still be served through Apache Tomcat, but it's going to be less efficient than using a dedicated Apache HTTP server. So throughout the last few decades, really, Apache's proven to be a staple in many popular stacks and actually the backbone of the early internet. Now, its popularity is kind of declining these days, and the options of web server choices are definitely increasing, but you see Apache still plays a pivotal role in many technology stacks and companies' system infrastructure. Even with new technologies and servers coming online and pretty much they're coming out nonstop, Apache is still a technology every developer needs to know how to handle and configure. All right, so that wraps up Apache Web Server. We got more in store. I'll see you in the next video.